Picture a planet where the sun never rises and never sets. On one side, eternal day, scorching, blinding, inescapable heat. On the other, endless night, frozen, star-filled, and cold as death. No sunrise, no sunset, no seasons, no shadows that ever move. This is the strange reality of tidal locking, a phenomenon where a planet's rotation becomes perfectly synchronized with its orbit. One side always faces its star, the other never does. And it's not science fiction. In fact, tidal locking is common across the cosmos. It's how our moon faces only one side to Earth. It's how many planets and other star systems likely exist, including dozens of so-called habitable super-Earths. But the effects of tidal locking go far beyond strange sunlight. It can reshape climates, warp atmospheres, influence biology, destroy magnetospheres, and maybe even decide whether life can ever emerge. Today, we journey to the twilight zones of these alien worlds to uncover the weirdest, wildest consequences of tidal locking. To understand tidal locking, we have to look at how gravity really works, not just as a force that pulls, but as one that stretches. When two bodies, say a planet and its star, pull on each other, they raise tidal bulges. We see this on Earth as ocean tides. But over time, those bulges exert torque. Friction slows the rotation of the smaller body, and eventually, it becomes locked. The result? It spins once for every orbit, so it shows the same face to its partner at all times. It's already happened to many objects in our solar system. Our moon is tidally locked to Earth. Pluto and Charon are locked to each other. Many moons of Jupiter, Saturn, and Neptune are locked to their parent planets. And beyond our solar system, around red dwarf stars, the most common stars in the universe, many planets orbit close. And close orbits mean strong tidal forces, meaning many exoplanets we've found are almost certainly tidally locked, which leads to a profound question. Can a world like that ever support life? Let's imagine life on a tidally locked Earth. One hemisphere constantly faces the sun. It's in permanent daylight, baking under unfiltered radiation, with the sun fixed high in the sky. Temperatures soar. Water evaporates. Clouds may never form. The opposite side, perpetual darkness. No sunlight, no warmth. Temperatures plunge to hundreds of degrees below freezing. Atmosphere may condense. Oceans might freeze solid. In between the two lies the terminator, the narrow twilight strip between day and night. A place of balance, perhaps. A thin habitable zone where warmth and cold meet, where day and night share the sky forever. This split world can lead to bizarre conditions. Jet stream level winds racing from hot to cold. Super-rotating atmospheres with hurricane force gales circling the planet. The possibility of boiling oceans on one side and ice sheets miles thick on the other. A sky that never changes, with fixed stars and a motionless sun. It's like a planet split in two. One side hell, one side frozen. Life, if it exists, would have to adapt to an alien kind of constancy. One of the most extreme effects of tidal locking isn't even visible from space. It's what happens to the atmosphere. On Earth, heat is distributed by winds, ocean currents, and a rotating planet. But on a tidally locked world, circulation becomes chaotic. The hot side creates rising columns of superheated air, while the night side sees perpetual sinking cold fronts. If a planet has a thick enough atmosphere, it might distribute heat across hemispheres, smoothing the extremes. But if the atmosphere is thin, or if the gravity is low, the air itself could freeze out on the dark side. Carbon dioxide might condense into dry ice. The night side might develop an atmosphere made of solid gas. And then there's the wind. Models predict constant supersonic winds near the terminator, jet streams that circle the globe, storms that never move, hurricanes that stay parked for centuries. Weather becomes a locked loop, a broken system with no seasons, no cycles, just thermal war. On Earth, our magnetic field protects us from cosmic radiation. It's generated by the motion of molten iron inside our spinning core, a planetary dynamo. But what happens to that dynamo when a planet stops rotating? Many tidally locked planets rotate very slowly, some not at all. And without rotation, the dynamo may shut down. The result? No magnetic field, no protection from solar flares. Radiation slams into the atmosphere, stripping it away molecule by molecule. This might explain why Mars, which spins slowly and lacks a strong field, lost its atmosphere long ago. For tidally locked planets, especially those around active red dwarfs, this becomes critical. Because red dwarfs are not quiet stars. They flare. They blast ultraviolet. They shoot out charged particles. So for a tidally locked world to survive, it either needs a thick atmosphere that can endure bombardment, a way to replenish its gases, or an unusual internal structure that keeps the magnetic field alive despite the lock. Without one of these, it may become a bare, sterile rock, scorched on one side, frozen on the other. And yet, despite it all, some scientists believe life might thrive on a tidally locked planet. Not on the day side, not on the night side, but in the terminator zone, the narrow band between extremes. Here, temperatures might be moderate, water might stay liquid, winds might circulate nutrients in clouds. The conditions could resemble a permanent dawn or dusk. Imagine a biosphere adapted to eternal twilight. Plants evolving under reddish, dim light. Organisms using wind energy instead of sunlight. Creatures with heat-sensitive vision, able to navigate gradients of thermal radiation. Entire ecosystems stretched in a ring around the globe, marching endlessly along a path where light just barely touches the horizon. Even more strange, intelligent life on such a planet might never invent timekeeping. With no day-night cycle, no seasons, and no stars that change position, what is a day? To them, change might be measured by migration, wind shifts, or magnetic anomalies, not by sunrise. This isn't all theory. We've found hundreds of exoplanets around red dwarfs that likely are tidally locked. Proxima Centauri b, just 4.2 light-years away, orbits in the habitable zone of its star and is almost certainly locked. TRAPPIST 1e, F, and G, part of the most famous exoplanet system to date, orbit close to a tiny, cool star and are probably locked too. Many super-Earths and mini-Neptunes discovered by TESS, Kepler, and JWST orbit red dwarfs within tight orbits, again, likely locked. The question isn't whether these planets exist. They do. The question is, what's it like to live on one? Could they support oceans, climates, and life? Or are they doomed to be cosmic half-worlds, baking and freezing in silence? Only deeper observation, and perhaps one day, interstellar probes, will tell. Tidal locking sounds like a curse, a limit, a death sentence for habitability. But perhaps that's not. Maybe it's just different. Maybe the universe is full of locked planets, with windswept twilight bands, ring-shaped forests, and alien life evolved for stillness, not change. Maybe we're just beginning to grasp the diversity of worlds that nature can create. Because not every planet spins like Earth. Not every sunrise matters. And not every form of life needs day and night. So when we gaze into the stars, searching for other Earths, Let's not just look for the familiar. Let's look for the weird, the locked, the asymmetric, the extreme. Because somewhere out there, on a tidally locked planet orbiting a quiet red sun, life may already be watching its eternal sky, wondering if they're alone, too.